Okay, I wanted to do a recording of just a few more problems from section 2.4. One of the problems that looks kind of difficult is 2 over 1 plus I minus 3 over 1 minus I. And one of the reasons I chose this one is you're supposed to do the math, and then you're supposed to, simplify your result or put your result in standard form. I was trying to get rid of that mark on the bottom, but apparently it happened pretty early on and I didn't notice it. All right, if I'm trying to subtract these fractions, I need to get a common denominator. And so I've got 1 plus I and 1 minus I on the bottom. This is an interesting problem because you start seeing what happens when you have conjugates. Because if you look at these denominators, they are conjugates of each other. They are not the same. So if I get the common denominator, this 1 plus I needs a 1 minus I. And I need to multiply by 1 minus I over 1 minus I. I'm just multiplying by 1 in that funky form, right? And then this fraction over here needs a 1 plus I to have a like denominator. So I'll multiply by 1 plus I over 1 plus I. Now, here's what happens when you get conjugates and you multiply them, which is the reason they're such a useful tool in math and especially even in calculus. 1 plus I times 1 minus I, I'm going to just work on the denominator first. We have the common denominator now, but let me go ahead and multiply it out. That's the difference of two squares pattern, and if you think about the difference of two squares, a minus b times a plus b is a squared minus b squared. Okay, so if I can multiply this out the long way and simplify it, or I could do it a lot quicker if I just say your a is 1, so 1 squared is 1, and you're subtracting I squared. But what is I squared? It is negative 1. So it's 1 minus minus 1, which ends up meaning that you have a denominator over here of 2. So now all I've got to do is simplify the numerator. 2 times 1 is 2, and 2 times negative I is minus 2I. I'm going to distribute a minus 3 here, okay? Minus 3 times 1 is minus 3, and minus 3 times I is minus 3I. If I clear that up, I've got, let me do the numbers first. The reason I'm going to do the numbers first is in standard form, you put the real number part first, and then you put the imaginary part second. That's the part that goes with the I. So I'll just do it in that order so we have our answer in the right order, since it wants us to put it in standard form. So 2 minus 3 would be negative 1. Took care of those. I have now a minus 2I, minus 3I, that would be minus 5I. Okay, so there's my answer, but it's not quite in standard form. If they're being really picky, they're going to write it as negative 1/2. It's negative 1 over 2 minus 5 over 2I. They're going to split it up that way because the real number part is this 1 over 2, and then you'd also put the second term. Negative 5 over 2 would be the coefficient of the I. So this is technically what it should be in standard form. I also want to look at 51. I know I'm kind of going backwards here, but I'm trying to fit the things I'm worried about the most on the video because I know time is short when I do the videos. All right, so 51 tells us to write the quotient in standard form. Okay, it's 4 minus 5I squared. And if we're going to put it in standard form, part of standard form is having it in a plus bi form. Another thing is we never want i's in the denominator. It's just a big no-no. Radicals are considered kind of a no-no. Imaginary numbers in the denominator, a no-no. Okay, at least this year sometimes things change and you get in upper level math. Okay, so now if I want to get rid of these 4 minus 5i's squared, how do I do that? Well, that's what conjugates are for. Did you notice in the last problem when we multiplied it out and we had the conjugates, we got a nice whole number of 2? Well, that's what we want to do here. We want to get that same thing to happen. I have 4 minus 5i, but if you think about it, I actually have 2 copies of it. I'm going to kind of write them like this for a minute. If I want the conjugate, I need each one of them to have the conjugate, and the conjugate of something minus 4 minus 5i would be 4 plus 5i. I'll just write it down, surely. Hopefully you understand about the conjugates from the other video I posted if you need it. Okay, so both of those need a 4 minus 5i. Okay, so now you might think, oh my gosh, that's 4 things to multiply out, but what if I group them, I wrote them differently anyway. What if I group this one together and this one together? So let me do the first thing. They're really the same thing, aren't they? 4 4 minus 5i times 4 plus I. If you think about that, that's in a difference of two squares pattern, a minus b, a plus b. So I can save myself some time and not distribute if I realize that's going to be a squared minus b squared. A is 4, 4 squared is 16. And b is, I'm going to subtract, and then 5i, if I squared that, that would be 25i squared. But 25i squared, if I squared is negative 1, and it is, you get negative 25. So it's 16 minus 25, which is, if you do that subtraction, isn't that negative 9? Oh, wait a second. It's 16 minus 25. Sorry. That's going to be 41. That's really 41. All that first thing. And then the second thing is also the same thing. So we get 41 times 41 on the bottom. And let me multiply that out on a calculator because I'm being lazy. That is 1681 on the bottom. Now, the thing about it is as I was creating these conjugates on the bottom, one thing that I should have done that I did not do was every time I put one on the bottom and added that in, I should have put it on the top, shouldn't I? So at least I wrote them in red so you can see what you need to copy up there. Before I multiply all that out, let me just multiply 4 plus 5i times 4 plus 5i. That is a perfect square pattern. And we talked about that in class, but if you don't remember the perfect square pattern, you can always just long multiply that out. That's going to be 16 plus 20i. And then when you distribute the 5i times 4, that's another 20i. And 5i times 5i is 25i squared. So we've got to simplify all that. And we know it goes over 1681 now. That would be, let me just kind of come down here and work because I don't have enough space. I'll run over some things I already wrote over there. That would be I times, okay, now we saw that 25i squared was actually negative 25. So I'm adding a negative 25 here. And I got a 16 here. So 16 minus 25 is, what, negative 9? And then I've got these 20i plus 20i, which is 40i. All over 1681. And then if I multiply the i's out, it's now distribute the I, that's negative 9i plus 40i squared. But I squared is negative 1, so this plus 40i squared becomes negative 9i minus 40. Because 40 times negative 1 is negative 40, so plus a negative 40 would mean subtract 40. Over 1681. They want it in standard form. I'm going to have to go to a new page. If I had minus 9i minus 40 over 1681, so technically to write it in standard form, it would be this. Oh, wait, that's actually backwards. I just split the fraction up, but now remember the real number part goes first. You can check to see if that reduces. I think we did check and it didn't reduce. And then the I part goes second. So I'd rearrange it, and technically that would be the answer if I write it in standard form, and they did ask me for that. Another one I want to just comment on while I'm here, and I have some room on the page, is number 45. If I want to get rid of the I in the denominator, and that's really what I got to do first, I may not know what all I need to do, but I do know I need to get rid of I in the denominator. If I just multiply by another I, and if I do it to the bottom, I got to do it to the top, I would end up with I squared on the bottom, and I squared is just negative 1, okay? Now what do I have on the top when I clean all that up? 6 times I is 6i, so it's 6i over negative 1, which is negative 6i. And if you're writing it in standard form, and they actually want you to write a plus bi, you could write, well, there's no real number part, or I could say the real number part is 0, and then it would be 0 minus 6i. That would be what the answer would be in standard form. Okay, for 57, it's negative 6i cubed plus I squared. They want us to put it in standard form. Now, I could write I cubed as I squared times I, and the reason I do that is that I know that I squared is negative 1. And that'll get rid of some of that, right? And then this I squared is also negative 1, so that would be minus 1. Negative 6 times negative 1 would be a positive 6i minus 1, and if I write it in standard form, it would be negative 1 plus 6i if I write it in the a plus bi form. Let's talk about how to graph this one, because you have a lot of problems on graphing here. When you graph complex numbers, you put the real part on the x-axis and you put the imaginary part on the y-axis. So if I look at this, my real part's negative 1 and my imaginary part is 6, I would graph that as I would graph the point negative 1, 6. So here's negative 1, and then 1, 2, 3, 4, 5, 6. I'm sorry, negative 1, 6 would be, let me graph it in a different color, would be right here if I'm counting by ones. Here's my negative 1, 1, 2, 3. So that's how I'm doing my axis here. That's what it would look like. So all those graphing ones, you're just kind of picking it off. You're actually just the real number part is your x-coordinate, the imaginary part is your y-coordinate.